Greetings, ladies and gentlemen. In this video, we are going to start solving this past paper, which is the Science Paper 1, 2024 GCE. As we can see on the front page given here. Okay, without wasting much of our time, let us get down into business. Question 1. The diagram shows a simple pendulum that swings from A to C and back to B in 0.75 seconds. The question continues. What is the period of oscillation? A. 0.56 seconds. B. 0.75 seconds. C. 1.00 seconds. D. 1.20 seconds. Okay, so to answer this question, we need to remember that 4 quarters make one oscillation, or 4 quarters make one swing. Okay, so we can see here that we have 3 quarters. So let us come up with the data so that we can see the number of oscillation. So we have 3 quarters. We have 3 quarters. So we are going to say 3 out of 4. 3 out of 4. The time we have been given, which is 0.75 seconds, and the number of oscillation. The number of oscillation is 3 over 4, which is 0.75 swings. Let us now bring the formula. So we are going to say the period of the pendulum is equal to time divided by number of oscillation. Okay, the period of the pendulum therefore is equal to 0.75 seconds divided by 0.5 seconds, 0.5 swings, or 0.5 oscillation. 0.75 divided by 0.75, we are going to get 1.00 seconds. So 1.00 seconds is our answer. So our correct answer here is C. We move to the next question. Which is question 2. Question 2 reads, a person fell from a transmitter of height 80 meters. Ignoring air resistance, calculate the time taken for the person to hit the ground. A. 4 seconds. B. 8 seconds. C. 9 seconds. D. 16 seconds. So to answer this question, we are going to come up with the data. Okay, so this person is jumping, or this person is coming from the transmitter of height 80 meters. Okay, so we know that the initial velocity is 0. Why are we saying so? This person is starting from rest. Okay, the person is jumping from the transmitter, so the initial velocity is 0 meters per second. Then the distance, since we are talking about the distance in vertical, the distance is height, and the distance is equal to 8 meters per second. And the acceleration we are talking about here is gravitational acceleration or field strength. Okay, gravitational acceleration, which is 10 meters per second squared. So therefore, we are going to say distance is equal to initial velocity times time plus 1 over 2 or plus half times acceleration due to gravity. So since we are talking about the distance in the vertical axis, we are going to use height. Okay, we are going to use height. So if we write 0 here and we say 0 times time, we are going to get 0. So therefore, we are going to remain with this. So where there is A, we have written G. Okay, where there is A, we have written G. The next thing that we are going to do, we are going to plug in the values we are given. So where there is height, we are going to write 8 meters. Then where there is gravitational acceleration, we have written 10. Let us work out. We have 8 is equal to 5 is equal to 5t. Okay, is equal to 5t. So to calculate the value of t, we are going to say 5t is equal to 8. Here divide by 5. 5 and 5 will cancel. 8 divided by 5, we are going to get 16 seconds. So 16 seconds is our answer. So therefore, our correct answer here is D. We move to the next question. We move to the next question, which is question A3. Question A3, an astronaut can jump through a greater vertical distance on the moon than on Earth. This is because the gravitational field strength is A, constant on Earth, B, greater on the moon, C, less on the moon, D, the same on the Earth and on the moon. Okay, so we need to remember that gravitational acceleration is different on Earth and moon. So the gravitational acceleration of the Earth is 10 meters per second squared, and gravitational acceleration of the moon is 1.67 meters per second squared. So we have seen that the gravitational acceleration of the moon is smaller than the gravitational acceleration of the Earth. So because of this, a person can fail, or a person can fall from the greater vertical distance without having injuries, because there is less gravitational acceleration on the moon. So we are going to say less gravitational acceleration on the moon. Our correct answer is C. Let us move to the next question, which is question A4. Question A4 reads, a 100 centimeters uniform beam is balanced when pivoted at X. A mass of 200 rests on the beam as shown in the diagram. Okay, so we are told that this beam is uniform. Okay, this beam is uniform. Then the question continues, what is the mass of the beam? A, 100 grams, B, 200 grams, C, 400 grams, D, 800 grams. Okay, so to find the mass of the beam, which is this one, we are told that this mass of the beam is uniform throughout. So since this mass of the beam is uniform throughout, the center of gravity should be in the middle. So the length of this beam is 100 centimeters. So therefore, the center of gravity should be, or the center of mass should be on 50, should be on 50 centimeters. But we have seen that according to the pivot given here, the center of gravity has been shifted to 40. Here we have 60, here we have 40. 20 plus 20 is equal to 40. Okay, 20 plus 20 is equal to 40. So we are going to bring this. We are going to say summation of clockwise moments is equal to summation of counterclockwise moment. Okay, is equal to summation of counterclockwise moment. So here we are not going to use moment of forces. So the reason why we are not going to use moment of forces, we have been told to find mass. Okay, we've been told to find mass, and according to the answers given here, the answers are in grams. So we are not going to convert the mass given to force, and we are not going to convert the grams to kg. There is no need, because the answer given here are given in grams. So we are going to maintain grams. Okay, we are going to maintain grams. So even if we convert grams to kg, they will still cancel, or we'll still convert them back to grams. So we are not going to stress ourselves by converting grams to kg. Okay, to kg. So remember, I said the center of gravity should be on 50, should be on 50 centimeters. So here we have 40 centimeters. So we are going to add 10 centimeters. We are going to add 10 centimeters so that we can have 50 centimeters. So this is where the center of gravity will be. Okay, this is where the center of gravity will be. So therefore, we are going to say mass times distance is equal to mass 1 times distance 1 is equal to mass 2 times distance 2. Okay, do we have mass 1? Do we have mass 1? Yes, we have mass 1, which is 200 grams. Do we have distance 1? Yes, we have distance 1, which is 20 centimeters. Do we have mass 2? Mass 2 is what we are looking for. Do we have distance 2? Distance 2, distance 2 is 10 centimeters. Why are we saying 10 centimeters? This is where the center of mass, or the center of gravity of the beam is. Okay, so let us work out. So we are going to say 200 times 20, we are going to get 4,000. We are going to get 4,000. Here divide by 10, here divide by 10. So mass 2 therefore is equal to 400. So our correct answer here is C. Our correct answer is C. We shift to the next question. We shift to the next question, which is question A5. Question A5 reads, which types of surfaces are best absorbers and best emitters of infrared radiation? Okay, A, best absorber, black and dull. Best emitter, black and dull. B, best absorber, black and shiny. Best emitter, white and dull. C, best absorber, white and dull. Best emitter, black and white. D, best absorber, white and dull. Best emitter, white and shine. Okay, so let me bring the diagrams here. So we have seen that dark and dark and black are good absorbers. Why are we saying so? We can see a huge beam of light absorbed by this black substance. Okay, by this black box here. Okay, we also need to remember that black and dull are good emitters. Why are we saying so? We can see a huge beam of light emitted by this black box. So therefore, our correct answer is A. Our correct answer is A. We shift to the next question, which is the question A6. Question A6 reads, the following diagram shows a sealed gas cylinder containing a fixed mass of gas. The piston is moved from position 6 to position 3. The temperature of the gas does not change. Okay, we are given the cylinder here. The question continues, what happens to the pressure of the gas when the cylinder is moved as stated? The pressure of the gas becomes A, doubled, B, equal to the atmospheric pressure, C, less by half, D, more by half. Okay, so to answer this question effectively, we are going to apply Boyle's law. Boyle's law states that the pressure of gas is inversely proportional to its volume, provided the temperature is kept constant. Okay, provided the temperature is kept constant. We also need to remember another concept which states that when volume reduced by half, remember we are told that the initial volume was 6, then the volume has been reduced by half. So when volume reduces, or if volume reduces by half, the pressure will increase by half. Okay, or let me say it in this way: the the pressure will be doubled. Okay, the pressure will be doubled. So when the volume reduces by half, pressure will be doubled. Pressure will be doubled. So our correct answer therefore is A. Our correct answer is A. We shift to the next question. We shift to the next question, which is the question A7. Question A7 reads, a drum of water of mass 200 kg is rolled up a plank of length 4 meters onto a platform 2 meters high. Take gravitational acceleration to be, or take gravitational strength field to be 10 Newton per kg. We are given the inclined plane here. What is the mechanical advantage and work done on the drum against gravity? Okay, so we are told that this drum is moving up using the slope given, and the length of the slope is 4 meters. So it is moving like this up to the top. Okay, it is moving like this up to the top. So let us come up with the data. We come up with data. What have we been given according to our question? So according to our question, we are given length. The length covered by the drum is 4 meters. Then the height is 2 meters. Gravitational acceleration is 10 Newton per kg. Okay, per kg. Then we are going to convert. We are also given mass, which is 200 kg. We are given mass, which is 200 kg. Let us find force. Force is equal to 200 times 10. 200 times 10, we are going to get 2000 newtons. 2000 newtons. What else do we need to have? To find the mechanical advantage, we are going to say mechanical advantage, MA is equal to length divided by height. MA is equal to length divided by height. So the length is 4 meters, then the height is 2. So 4 divided by 2, we are going to get 2. So the mechanical advantage is equal to 2. Okay, the mechanical advantage is equal to 2. To find work, we are also going to say work is equal to force times distance. Force times distance. So force, we are from finding force, which is 2000 newtons. Do we have distance? Yes, we have distance, which is height. So remember here, we need to be very careful. The distance that we should pick is this one, the height, not this one. Okay, not the slope, but this one. So we are going to say 2000 times 2. We are going to get 4000 joules. So therefore, work is 4000 joules. Mechanical advantage is 2. Okay, mechanical advantage is 2. So here, I think there was a mistake when setting this question. Yes, we have the work done, which is 4000, but mechanical advantage, the 2 which is here is not matching with the the work done. Okay, the work done. So our suspected answer is, or our preferred answer here, since we don't have the one that is showing mechanical advantage 2 and the work done 4000 joules. So if we round off this one, we can come up with 2. But these are my suggested answers. So if at all you have a different answer, you are free to comment. We shift to the next question, which is question A8. Question A8. A radio station emits radio waves at a frequency of 60 mHz. What is the wavelength of the what is the wavelength what is the wavelength of the waves? What is the wavelength of the waves? Okay, so to answer this question, we need to remember that mid-haze, okay, mid-haze make, sorry, not mid-haze, mega-haze make 1 million haze. Mega-haze make 1 million haze. And the speed of light, we know that the speed of light is 2.9 times 10 to the power 8 meters per second. Or we can just say 3 times 10, 3 times 10 to the power 8 meters per second. Data. What have we been given according to our question? So we are given frequency, which is 60 million haze, 60 million haze, or we can say 60 times 10 to the power 6 haze. So we have converted the mega haze given into haze. What else have we been given? We are also given the speed of light, which is 2.9 times 10 to the power 8 meters per second. So to find the wavelength, we are going to say wavelength represented by lambda is equal to speed of light represented by c over frequency represented by f. So the speed of light, which is 2.9 times 10 to the power 80, divided by 60 times 10 to the power 6, we are going to get 5 meters. Okay, we are going to get 5 meters. So therefore, our correct answer here is 5 meters. Our correct answer is 5 meters. Remember, this is an exponent, this is an exponent, or this is a power, this is a power. This is not 108, but 10 to the power 8. This one also is not 106, but 10 to the power 6. Okay, we move to the next question, which is question A9. Question A9 reads, the diagram shows a water wave generated by a stone thrown in a pool of water. The question continues, what is the value of the period and the frequency of the wave? The first column, we are given period in seconds. The second column, we are given frequency in hertz. So to answer this question, we are going to say period is equal to time divided by number of waves. Period is equal to time divided by number of waves. So here we have a complete wave. Here we have a complete wave, and the distance moved by the complete wave is, I mean, the time. By the way, finding the period here, we can use two methods. We can just pick the period direct from the diagram. What is period? Period is the time taken to make a complete wave. So we have seen that the time here is 20 seconds. 20 seconds. So remember, 4 quarters make one complete wave. 1, 2, 3, 4. We make a complete wave. Okay. Then here we have 3. Here we have 3 quarters. 1, 2, 3, 4. So we are going to make one complete wave and 3 quarters. One complete wave and 3 quarters. So the number of waves therefore is 1 and 1, or number 3 over 4, which is 1.75 waves. 1.75 waves. Then the time taken to complete these waves is 35. So here it is 35. So as we can see, here we have 20. Here we have 20. So between 20 and 30 we have 25. Between 30 and 40 we have 35. So this is 35. So the number, the time it is taken to complete, or the time it is taken to make 1.75 waves is 35 seconds. 35 seconds. So we are going to say 35 seconds divide by 1.75. We are going to get 20 seconds. Let us also find the frequency. Frequency is equal to, of course, there are a good number of formulae we can use to find the frequency. So to find frequency, we are going to use this formula. Since we have the period, we are going to say frequency is equal to 1 divided by period. Frequency is equal to 1 divided by period, which is 20. So 1 divided by 20, we are going to get 0.05 Hz. So therefore, our correct answer here is B. Periods 20.0 seconds, frequency 0.05 Hz. We are done with this question. Let us move to the next question. We move to the next question, which is question A10. Question A10, a ray of light enters a block of glass from air and emerges at an angle of 25 degrees. What is the angle of incidence of the ray if the refractive index of glass is 1.5? If the refractive index of glass is 1.5. So to answer this question, let us come up with the Snell's law, which states that Snell's law states that the ratio of the sine of the angle of incidence to the sine of the angle of refractive is always constant. Okay, and this is called refractive index. So this is the law that we are going to apply here. This is the law that we are going to apply here. So we are going to say index is equal to sine E. Index is equal to sine E. Incidence angle or angle of incidence degrees divided by sine angle of refractive ray degrees. We come up with the data. So we are given the angle. We've been given the angle. We've been given the angle of the deflection, which is 25 degrees. We are also given deflective index, which is 1.5. So let us see, plug in these values. So where there is deflective index, we have written 1.5 seconds. Then where there is sine R, we have written 25. We have written 25. We do a close multiplication. We are going to get sine I representing incidence angle or incident angle is equal to sine 25 is 0.633927392. Okay, sine, we find the inverse of sine I, and we find the inverse of sine 0.633. We are going to get 39.34 degrees. So therefore our correct answer is C. Our correct answer is C. We move to the next question, which is question A. Question A11. Question A11. The following diagram shows two rays of light passing through a lens in region X. Which type of lens in region X and which type of image is formed? Which type of lens is in region X and which type of image is formed? Okay, so the type of lens is converging lens. So it's converging lens. Okay, so when the object is standing between F and 2F, the image will be bigger than the object. Okay, the image will be bigger than object, and the characteristics of the image that will form the image is invented or upside down. The image is real. The image is magnified. Okay. Or we are simply saying the image is bigger than the object. So therefore, the lens is converging. The lens is converging lens, and the type of image is real. Okay. We are done with this question. Let us move to the next question, which is question A12. The following diagram shows magnetic field lines around two magnets. Which of the following is true about P, Q, R, T, and S? Okay. So we need to remember that magnetic poles with magnetic fields pointing outwards are north poles, while those pointing inwards are south poles. Okay, are south poles. And here, this is the neutral point. This is the neutral point. So therefore, P is the south pole, Q north pole, R north pole, T south pole, X. We move to the next question, which is question A13. Question A13 reads: the following diagram shows a negatively charged rod brought near a metal sphere on an insulated stand, and the metal sphere was earthed. Later, the rod was removed and the earthing also removed. What will be the net charge possessed by the metal sphere? A, both negative and positive. B, negative. C, neutral. D, positive. So we need to remember that like poles repel, opposite poles attract. Okay, so since this one is negatively charged, the moment we bring it here, it will push the negative charges to this side, then the positive charges will be here. Okay, then if we earth this sphere, all the negative charges will run to the earth, then this one will remain with the positive charges only. So therefore, our correct answer is D, positive charges. We move to the next question, which is question A14. Question A14, how long will it take to charge a cell phone battery to a charger of 54 coulombs using a voltage of 6 V and a current of 2.5 amperes? A, 0.06 hours. B, 2.16 hours. C, 13.5 hours. D, 21.6 hours. 21.6 hours. So to answer this question, we are going to say quantity is equal to current times time. Quantity is equal to current times time. Okay, so changing the subject of the formula, we are going to have time is equal to quantity divided by current. Data. So what have we been given according to our question? So according to our question, we have seen that we are given 54 columns. We are given 54 columns. We are also given we also need to remember that 1 amperes make 1000 milliamperes. 1 amperes make 1000 milliamperes. So since we have been given current in milliamperes, we are going to convert it to amperes, which is 0.0025 amperes. Okay, so therefore we are going to say time is equal to 54 divided by 0.002 amperes, and we are going to get 21,600. Okay, so the time has been given in seconds, so we need to convert time to hours. So we need to remember that we need to remember that 1 hour make 3,600 seconds. So converting 21,600 seconds to hours, we are going to get 6 hours. We are going to get 6 hours. So there was a mistake here. We don't have 6 hours, but our correct answer should be 6 hours. We shift to the next question, which is question A5. Question A5, question A15, so to say, question A15. The cost of electricity for using a kettle is 8.00 at a cost of 0.65 per unit kilowatt hour. It takes 5 minutes to boil water in a day, and the kettle is used for 30 days. What is the power rating of the kettle? What is the power rating of the kettle? Okay, so to solve this question, we are going to come up with the data. We are going to say power is what we are looking for. Then the total cost of electricity is 8 kwacha. Then the rate is 65 ngwe per kilowatt hour. Then the time we are going to say 5 seconds times 30 days. We are going to get 150 minutes. We convert 150 minutes to hours. We are going to get 2.5 hours or 2.5 hours or 2 hours 30 minutes. 2 hours 30 minutes. Then we are going to bring this formula. We are going to say cost is equal to power times time times rate. So the cost of electricity is 80. Then power is what we are looking for. Time we have 2.5 hours or 2 hours 30 minutes. Rate we have 65 ngwe. We have 65 ngwe. Power is equal to, so the 80 is equal to 2.5 times 0.65. We are going to get 1.625 P. Here divide by 1.625. Here also divide by 1.625. Power is equal to 49 kwacha 23 ngwe. So we are looking for power. So power is equal to 49.23 kilowatts. Okay, so our correct answer therefore is C. Our correct answer is C. We shift to the next question, which is the question S16. A transformer has 1,800 turns on the primary coil. The voltage applied to the primary coil is 240 AC. How many turns are on the secondary coil? If the output voltage is 40, are the A 150 turns, B 300 turns, C 6,000 turns, D 9,200 turns. 9,200 turns. So to answer this question, let us come up with data. Okay, so the number of turns in the primary coil is 1,800. Then the number of turns in the secondary, we don't know. Actually, we are looking for the number of turns in the secondary. The voltage in the primary is 240 volts. Then the voltage in the secondary is 40 volts. Okay, 40 volts. So we are going to say voltage in the primary divided by voltage in the secondary is equal to number of turns in the primary divided by number of turns in the secondary. Okay, so voltage in the primary is 240 divided by voltage in the secondary, which is 40, is equal to number of turns in the primary is 1800 divided by number of turns in the secondary. We do a cross multiplication, we are going to get 240 number of turns in the primary is equal to 72,000. Here divide by 240, even here divide by 240. We are going to get 300 tens. So therefore our correct answer is 300 tens. We move to the following diagram shows a simple AC generator. As we can see, we are given a diagram here. The question continues. What name is given to the part labeled Y? A. Axle. B. Carbon brush. C. Magnet. D. Slip ring. Okay, so we need to bear in our mind that the slip ring is an electromechanical device that allows transmission of power and electrical signals from stationary structures to rotating one. So therefore, the name given to the part labeled Y is called slip ring. Our correct answer is D. We move to the next question, which is question A18. Question A18, which particles are emitted by the hot filament of a cathode ray oscilloscope, CRO, and which type of field is used to accelerate them? So we are given two columns. The first column, particles. The first column we have particles. The second column we have type of fields or type of fields. Okay, so we also need to remember that in the cathode ray oscilloscope, the hot filament emits electrons, and electric fields are used to accelerate electrons towards the screen. So electric fields are the ones that are used to accelerate these electrons. Therefore, our correct answer is A. Our correct answer is A. We move to the next question, which is question A19. Question A19, which of the following shows the correct charge for alpha, beta, and gamma radiations? Okay, so we need to remember that the charge of alpha radiations is positive 2, and the charge of beta radiations is -1, and the charge of gamma ray is 0. So therefore our correct answer is C. Our correct answer is C. We move to the next question, which is question A20. A nuclide of strontium is represented by the symbol Cr 88 mass number and 38 atomic number or proton number. What does the nucleus contain? What does the nucleus contain? A. 38 electrons and 50 neutrons. B. 38 neutrons and 38 protons. C. 38 neutrons and 50 protons. D. 38 protons and 50 neutrons. Okay, so to answer this question, we are going to say protons and neutrons are found in the nucleus. Protons and neutrons are found in the nucleus. So we have the proton, which is 38. We have the proton, which is 38. So therefore we are going to say mass number, which is 88, is equal to 38 plus number of neutrons. So therefore number of neutrons is equal to 88 minus 38. We are going to get 50. So the number of neutrons is equal to 50. So we know that these two are found These two are found in the nucleus. So we expect to see 38 protons and 50 neutrons in the nucleus. So our correct answer is A. Without wasting time, let us now shift to section B. We shift to section B. Here we are expected to answer all questions. Question B1. Figure B1.1 shows an instrument used to measure a physical quantity. Question A. What is the reading shown on the device? What is the reading shown on the device? So the first thing that we are going to do is to identify the sleeve scale. So the sleeve scale before the beginning of the thimble scale is 8.5. Why are we saying 8.5? So this is 5.5, 6.5, 7.5, 8.5. So this is the 8.5. So to locate or to identify a mark on the thimble scale, we need to find the mark that is coinciding with the horizontal line that is coming from the sleeve scale. And this is the mark we are talking about. And this mark is 23. This mark is 23. This mark is 23. Okay. So this mark should be 22. This mark should be 22. So we are going to say main scale, which is the sleeve scale, is equal to 3.5. And we also need to remember that on the thimble scale, we need to multiply the mark we have found, which is 23, by 0.01 millimeters. So we are going to say we are going to say thimble scale is equal to 23 times 0.01. We are going to get 0.0. We are going to get 0.02. Remember, we have changed here. Here we should have 2 and here 2. Okay. So therefore, to find the final reading, we are going to say 8.5 plus 0.22. 8.5 plus 0.22. We are going to get 8.722. 8.722, not 8.73, 8.722. We move to the next question. We move to the next question, which is question B. Question B, name part P. Name part P. Okay. So part P, this part is a spindle part. Okay, as we can see here. So this is a spindle. So we are going to say spindle. Spindle. We are done with the question B. Let us move to question C. Question C. Okay, question C. What is the function? What is the function of the ratchet? Okay, what is the function of the ratchet? So the function of the ratchet is to ensure constant pressure applied to attain accurate measurements. Then the last question is saying, give one precaution you would consider when using this instrument. So this is a micrometer screw gauge. Okay, this is a micrometer screw gauge. Number one, we need to make sure that the envoy and the spindle, the envoy and the spindle are clean before using this instrument. Okay, to avoid wrong readings. We are done with this question. Let us move to the next question. We move to the next question, which is question B2. Figure B2.1 shows a wheel and the axle for a simple machine used to lift a load of 240 newtons when an effort of 60 newtons is applied. Question A, define a simple machine. So what is a simple machine? A simple machine is a device that makes work easy. A simple machine is a device that makes work easy. We are done with this question. let us shift to the next question, which is question B. Question B, calculate the mechanical advantage MA of the wheel and the axle shown. Calculate the mechanical advantage. So the mechanical advantage of the wheel and the axle shown, we are going to come up with the data. So what data have we been given? So we are given load, which is 240 newtons. We are also given effort, which is 60 newtons. So to find mechanical advantage, we are going to say mechanical advantage is equal to load divided by effort. So load is equal to 240 and effort is equal to 60. 240 divided by 60, we are going to get 4. So the mechanical advantage therefore is 4. By the way, mechanical advantage is a ratio, so we don't expect to see any units. So mechanical advantage has no units. So don't stress yourself by trying to figure out the unit you can put on the mechanical advantage. Mechanical advantage has no unit. We move to the next question, which is question C. If the rad of the wheel, capital letter R, and axle, small letter r, are 80 centimeters and 60 centimeters respectively, determine the velocity ratio VR of the wheel and the axle. Okay, so to answer this question, we are also going to collect data. We are going to say the big radius is equal to 8 centimeters and the small radius is equal to 16 centimeters. Velocity ratio is equal to capital letter R divided by small letter r. So 8 divided by 16, we are going to get 5. So the velocity ratio therefore is equal to 5. Velocity ratio is equal to 5. We move to the next question, which is question D. Question D reads, what is the efficiency of the wheel and the axle? What is the efficiency of the wheel and the axle? So the efficiency of the wheel and axle, the first thing we are going to do, we are also going to come up with the data. So we have the mechanical advantage, which is 4. We calculated the mechanical advantage in the first question. We also calculated the velocity ratio in the previous question, and we are looking for efficiency. So we are going to say efficiency is equal to mechanical advantage divided by velocity ratio times 100% times 100%. Do we have mechanical advantage? We have mechanical advantage, which is 4. Divide by 5 times 100% times 100%. We are going to get 400 divided by 5. We are going to have efficiency, which is 80%. So therefore, efficiency is equal to 80%. We move to the next question. Which is question B3. Question B3 reads, a glass-sided box containing a mixture of smoke and air is illuminated, and a microscope is used to view the motion of the smoke particles. Question A, Roman numeral 1, define diffusion. So what is diffusion? Diffusion is the movement of particles from the region of higher concentration to the region of lower concentration. We have answered the first question. We move to the next question, which is question E. Roman numeral 2 states 2 factors that increase the rate of diffusion. Here are the 2 factors that increase the rate of diffusion. Number 1, we have temperature. The higher the temperature, the higher the rate of diffusion. Number 2, we have concentration gradient. So concentration gradient concentration increases the rate of diffusion. So we have answered question 2. Now let us move to the next question, which is question B. Question B states two differences between boiling and evaporation. State two differences between boiling and evaporation. So here are the two differences. Number one, boiling occurs or take place throughout the liquid, while evaporation takes place at the surface of the liquid. Difference number two, we are going to say boiling occurs at a fixed temperature. So boiling, there is a temperature we call boiling temperature. So boiling occur at this exact temperature. Then evaporation take place at n temperature. Okay, evaporation occurs at n temperature. So we have answered question B3. Let us move to the next question, which is question B4. Question B4 reads, figure B4.1 shows the displacement distance graph for waves generated on a string. Question B4a, define wavelength of a wave. Define wavelength of a wave. Define wavelength of a wave. So we are going to say wavelength is the distance between two successive crests. Wavelength is the distance between two successive crests. Or we can say wavelength is the distance between two successive fluffys. Wavelength is the distance between two successive fluffys. Or we can say wavelength is the distance covered by a complete wave. Wavelength is the distance covered by a complete wave. Wavelength is the distance, or wavelength is the distance between two successive crests, or distance covered by a complete wave. Okay, we now move to the next question, which is the question 4b. Question 4b reads, state the wavelength of the wave in figure B4.1. State the wavelength of the wavelength of the wave in figure B4.1. Okay, so the distance between these two crests is 10. Okay, the distance is 10, or the distance covered by this complete wave is 10 centimeters. 10 centimeters. 10 centimeters. We convert it to meters, 0.1 meters. 0.1 meters. We have answered question B. Now let us shift to the next question, which is question C. Question C, what is the amplitude of the wave in figure B4.1? So the amplitude of figure B4.1 is the amplitude is 10 centimeters. Okay, the amplitude is 10 centimeters. So here we are going to say 10 centimeters. We move to the next question, which is question D. If the waves travel along the string at 0.5 meters per second, calculate the period of the waves in figure B4.1. Okay, so to find the period, we are going to come up with the formula, which is saying period is equal to 1 divided by frequency. Do we have frequency? Let us find the frequency. We find the frequency. So we know that speed is equal to frequency times wavelength. Speed is equal to frequency times wavelength. Do we have speed? Yes, we have speed. We have speed, which is 0.5 meters per second. Do we have wavelength? Yes, we have wavelength, which is 10 centimeters. 10 centimeters. We convert it to meters, 0.1 meters. So where there is V representing speed, we are going to write 0.5 is equal to F times 0.1. Okay, so 0.1 F is equal to 0.5. Here divide by 0.1, even here divide by 0.1. We are going to get 5. So frequency is equal to 5. Now let us find the period. So period is equal to 1 divided by 5. 1 divided by 5, we are going to get 0.2 seconds. We are going to get 0.2 seconds. So therefore, period is equal to 0.2 seconds. Period is equal to 0.2 seconds. Period is equal to 0.2 seconds. We move to the next question, which is question B5A. What type of energy is an infrared wave? What type of energy is in an infrared wave? So the type of energy in an infrared wave is electromagnetic energy or radiant energy. The type of energy in an infrared wave is an electromagnetic energy or radiant energy. We move to the next question, which is question B. Give the range of frequencies audible to the normal human ear. Okay, give the range of frequencies audible to the normal human ear. So the range is 20 Hz to 20,000 Hz. 20 Hz to 20,000 Hz. So if we want, we can even convert it to kilohertz. We move to the next question, which is question C. Define an echo. Define an echo. So an echo is a reflection, or an echo is the reflection of sound that is heard after it bounces off a surface. An echo is a reflection of sound that is heard after it bounces off. We move to D. A plane sends an ultrasonic sound down the ground and receives the echo after 4.8 seconds. How high is the plane above the ground? Take velocity of sound in air to be 340 meters per second. So to answer this question, we are going to say the speed of the sound, or the speed of an echo sound, is equal to 2 times distance divided by time. Okay, so why are we saying 2? Because the sound is covering 2 distances. The sound is bouncing back. The sound is bouncing back. Data collection. What have we been given? We have been given speed, which is 340 meters per second. What else have we been given? We have been given time, which is 4.8 seconds. 4.8 seconds. What else have we been given? We have been given, we are looking for distance. Okay, we are looking for distance. So where there is speed, we are going to write 340. Then where there is time, we are going to write 4.8 seconds. We do a close multiplication. We are going to have 2 times distance is equal to 340 times 4.8 seconds. We are going to get 1632. Here divide by 2, even here divide by 2. Distance therefore is equal to 800, is equal to 816 meters. 816 meters. So height is equal to 816 meters. 816 meters. We shift to the next question, We shift to the next question, which is the question E. Question E. Give one way in which sound pollution can be minimized. Give one way in which sound pollution can be minimized. So sound pollution can be minimized by using soundproofing materials such as acoustic panels, curtains, or double glassed windows to block unwanted noise. So this is one of the ways we can prevent sound pollution. This is one way of preventing sound pollution. We move to the next question, which is question B6. Figure B6.1 shows a lens used to form an image. Draw to scale. Question A. Identify the type of lens in figure B6.1. Identify the type of lens in figure B6.1. So the type of lens in figure B6.1 is the converging lens. Okay, it's called converging lens. We move to the next question, which is question B. Mention two characteristics of the image formed. Mention two characteristics of the image formed. So as we can see, the image that has been formed is bigger or larger than the object. The image is bigger or larger than the object. So therefore, we are going to say the image is invented, or the image is upside down, and the image is magnified or enlarged. The image is magnified or enlarged. Okay. We move to last part of question C. Last part of question C. What device uses this type of lens to produce similar type of image? What type of device uses this type of lens to produce similar type of image? So microscope is the one that uses this type of lens to produce a similar type of image. We are done with this question. Let us move to the next question. We move to the next question, which is question B7. Figure B7.1 shows resistors connected to 4V power supply. Question A. What is the effective resistance of the circuit? What is the effective resistance of the circuit? So to find the effective resistance of the circuit, we are going to say resistance, effective resistance. We are simply looking for the total resistance. We are going to say resistance in the series plus resistance in the parallel. So resistance in the series, we have 3 ohms. Resistance in parallel, let us find the resistance in parallel. So to find resistance in parallel, we are going to say resistance 1 times resistance 2 divide by resistance 1 plus resistance 2. Resistance in parallel is equal to 6 times 12 over 6 plus 12. So 6 times 12, we are going to get 72. 72 divided by 18. 72 divided by 18, we are going to get 4 ohms. Okay, we are going to get 4 ohms. And this is our resistance in series. Our resistance in series. So therefore, we are going to say effective resistance is equal to 3 plus 4. Effective resistance is equal to 3 plus 4, which is here. 3 plus 4, which is here. We are going to get 7. So therefore, the effective resistance is 7 ohms. 7 ohms. We move to the next question, which is question B. Name the potential difference PD across the 3 ohms resistor. Calculate the potential resistance across 2 2-ohm resistor. So to find the potential difference, we are going to say potential difference is representing voltage. So we are going to say voltage is equal to current times resistance. Current times resistance. Do we have um do we have the okay do we have current? Current is what we are looking for. So we are going to say to find current is equal to voltage divided by R. Okay, current is equal to voltage divided by R. So 4 divided by 7 is equal to 0.57 amperes. Current is equal to 0.57 amperes. Therefore, we are going to say potential difference is equal to 0.57 times 3. 0.73 0.57 times 3, we are going to get 1.71 voltage. 1.71 voltage. Okay, 1.71 voltage. So our potential difference here is 1.71 voltage. We move to the next question, which is question A80. Question A80 reads, Figure B8.1 shows a cathode ray oscilloscope CRO. Question A, name the process by which cathode rays are produced. Name the process by which cathode rays are produced. So the cathode ray, name the process by which cathode rays are produced by electronic emission or thermionic emission. We move to B, state the function of the Y plates in the CRO. So the function of the Y plates is to control the up and down vertical movement of electron beam or electrons. We have answered this one. Let us move to C. C, why is the potential difference between the cathode and the anode very high? Why is the potential difference between the cathode and the anode very high? Okay, in order to accelerate the electrons emitted from the cathode. So the reason why the potential difference between the cathode and the anode are very high is to ensure that electrons are emitted at a high speed from cathode. We have answered this one. Let us move to the next question, which is question B9. Question B9A, define nuclear fission. What is a nuclear fission? So nuclear fission is a process in which large atomic nucleus split into two smaller nuclei, releasing huge amount of energy. Okay, we have answered question A. Let us move to the next question, which is question B. What is background radiation? What is background radiation? So we are going to say background radiation is the low level natural radiation that is always present in the environment. We have answered this one. Let us move to the next question, which is question C. Stage 2 uses of nuclear energy. Stage 2 uses of nuclear energy. So number 1, the nuclear energy turns water into steam, which spins turbines to generate electricity. The nuclear energy turns water into steam, which spins turbines to generate electricity. Nuclear energy is also used in radiotherapy to treat cancer by destroying cancer cells. Okay, by destroying cancer cells. We move to the next question, which is question D. Complete nuclear equation. complete nuclear equation. So we can see a beta particle here. You can see a beta particle. So we need to remember that one of the neutrons found in the nucleus is converted to a proton. So therefore the proton will increase from 11 to 12. So therefore we expect magnesium to have 12 as its mass number. So we can also check on the timetable, on the periodic table, so to say. On the periodic table, we are going to discover that the atomic number of magnesium is 12. Then the mass number of magnesium is 24. So therefore, we are going to have the mass number, which is 24, and the atomic number 12. Then the beta particle will have a negative charge. A beta particle will have a negative charge. So if you remember very well, there is a question that we answered in section A. Okay, we were asked to give the charges of alpha, beta, and gamma, and we said the charge of the beta radiation is negative. So no wonder we have added a negative here. Okay, so we have completed the following nuclear equation. Now let us shift to section C. We shift to section C. Here we are expected to answer 2 questions. Since we are revising this paper, we are going to answer all 3 questions. Question C1A. Figure C1.1 shows results of velocity and the time recorded for an object that was dropped from a certain height on the surface of the moon. Question Roman numeral 1. Plot a graph of velocity meters per second against time seconds. The question is carrying 4 marks. Okay, the question is carrying 4 marks. So we need to use the table of values we are given. The table of values we are given. So time will be on the x-axis, then velocity on the y-axis. So let us come up with let us bring our graph here. We have our graph here. So the first coordinate is 0, 0. So 0, 0 is found here. So this is 0, 0. The second coordinate is 1, 1.6. So 1, 1.6 is found here. 1, 1.6 is found here. The next coordinate is 2, 3.2. 2, 3.2. So 2, 3.2 is found here. 2, 3.2 is found here. The next coordinate is 3, 4.8. 3, 4.8 is here. The next coordinate is 4, 6.4. 4, 6.4 is here. 4, 6.4 is here. The next coordinate is 5, 8.0. 5, 8.0 is here. 5, 8.0 is here. So as we can see, we have successfully managed to come up with a graph. Okay, so we are done with the first question. We are done with the first question. Let us now move to the next question. We move to the next question, which is question Roman numeral 2. Use the graph to determine the time when velocity was 4 meters per second. The question is carrying 2 marks. So therefore, we need to provide an answer that will attract 2 marks. Okay. So we are going to bring back our graph here. We are going to bring back our graph. So we are looking for time when velocity is equal to 4 meters per second. 4 meters per second. So when the velocity is 4 meters per second, time is 2.5 seconds. Time is 2.5 seconds. So therefore, we are going to say 2.5 seconds. We have answered question 2. Let us move to the next question, which is the question Roman numeral 3. Calculate the gradient of the graph. Calculate the gradient of the graph. Okay, so to find the gradient of the graph, we are going to say gradient is equal to y2 minus y1 divided by x2 minus x1. So these are two coordinates I've picked. So you can also pick the coordinates, two coordinates that you want here. Okay, so I have picked two coordinates. I have picked 1, 1.6 and 4, 6.4. So these are coordinates that I will use to find the gradient. These are coordinates I will use to find the gradient. So this is x1, this is y1, this is x2, this is y2. So where there is y2, we are going to write 6.4. And where there is y1, we are going to write 1.6. Okay. Where there is x2, we are going to write 4. Where there is x1, we write 1. Then we are going to say 6.4 minus 1.6. 6.4 minus 1.6, we are going to get 4.8. 4.8 divided by 3. 4.8 divided by 3 is equal to 1.6. Is equal to 1.6. Okay, is equal to 1.6. Is equal to 1.6. So therefore our gradient is 1.6. Okay, our gradient is 1.6. We continue. Okay, so we have answered this one. We have calculated the gradient, which is 1.6. Okay, the last question is this. This is not the last question. Okay, we'll see. What does the gradient of the graph represent? So the gradient of the graph represents acceleration due to gravity on the moon. Why are we saying acceleration due to gravity on the moon? So 1.6 is gravitational acceleration on the moon. So the gradient is representing acceleration due to gravity on the moon. We move to question B. State the principle of conservation of energy. State the principle of conservation of energy. So conservation of energy states that energy can neither be destroyed nor created, but it can be changed from one form to another. Energy can neither be destroyed nor created, but it can be changed from one form to another. Okay. We move to the next question, which is question C2. Question C2, figure C2.1 shows a waveform indicating voltage produced by a generator. Question C2, what type of electricity is produced by the generator? What type of electricity is produced by the generator? So the type of electricity produced by this generator is alternating. Sorry, yes, this is alternating current, AC, alternating current. We move to B. B, determine the maximum voltage produced by the generator. Determine the maximum voltage produced by the generator. So we have seen that the maximum is 5 volts. Okay, the maximum is 5 volts. We move to C. Question C states two ways. Question C states two ways in which electromotive force EMF produced by a generator can be increased. States two ways in which electromotive force EMF produced by the generator can be increased. Okay, number one, increasing the number of turns in the coil leads to greater total interaction with the magnetic fields, resulting in higher induced EMF. Okay, EMF. Number two, increasing the strength of the magnetic fields leads to greater voltage in the coil, increasing the amplitude of the waveform. Okay, so we have stated two ways in which electromotive force can be increased. Let us move to the next question. We move to the next question, which is question D. Define a transformer. What is a transformer? A transformer is an electrical device that transfers electrical energy between two or more circuits through electromagnetic induction. It is used to increase step-up or decrease step-down voltage levels while maintaining the same frequency. So we have given the definition of a transformer. Let us move to the next question. We move to the next question, which is question D. Draw a diagram of a step-up transformer. So a step-up transformer has small number of turns on the primary coil and a big number of turns in the secondary coil. So we have the step-up transformer here. So as we can see here, we have a small number of turns, and here we have a big number of turns. So this is a step-up transformer. This is a step-up transformer. We move to the next question, which is the question E, the last part of question C2. Explain why it is cheaper to transmit electrical power at higher voltage than at a lower voltage. So the reason why it is cheaper to transmit electrical power at higher voltage than at lower voltage is because it reduces energy losses due to resistance in the transmission lines. It reduces energy losses due to resistance in the transmission lines. Okay, we move to the next question, which is question question F. Sorry, this is not the last question. Question F. What does it mean to laminate the iron core of a transformer? What does it mean to laminate the iron core of a transformer? Laminating the iron core of a transformer means dividing the core into thin insulated layers, laminations, instead of using a single solid piece of iron. These thin layers are separated by insulating material, usually varnish or oxide coating, to reduce aid current losses. So this is what it means when they say laminate the iron core of a transformer. We are done with the question C2. Let us move to the last question, which is question C3A. Roman numeral 1, define nuclear fusion. So previously there was a question we were asked to define nuclear fission. Here we are asked to define nuclear fusion. So let us define nuclear fusion. So what is nuclear fusion? So nuclear fusion is a process in which two light atomic nuclei combine to form heavier nucleus, releasing significant or big amount of energy. Okay, we are done with this question. Let us move to the next question. We move to the next question, which is question 2. State two similarities between nuclear fusion and nuclear fission. Two similarities. So both nuclear fusion and nuclear fission release huge amount of energy. due to the conversion of mass into energy. Due to conversion of mass into energy. Both processes involve the changes in the nucleus of an atom, leading to the release of subatomic particles such as neutrons. Okay, so these are two similarities between nuclear fusion and nuclear fission. We have answered this one. Let us move to the next question. We move to the next question, which is the question. We move to the next question, which is the question. Okay, the next question, which is question Roman numeral 2. Write equation for the reaction of hydrogen 2 and hydrogen 1 to produce helium. Okay, so they want us to come up with the okay, we move to B. B, Roman numeral 1, name a device that can be used to measure nuclear radiation. So here we have a good number of devices that we can use to measure nuclear fusion. Number 1, we have spectrometer, measures the energy spectrum of particles emitted during fusion reactions. Number 2, we have neutron detector, detects neutrons released during fusion reactions. Number 3, we have interferometer, measures the density and temperature of the plasma. So these are some of the devices that we can use to measure nuclear radiation. So we are going to choose one. We have chosen neutron detector. Okay, we have chosen neutron detector. We move to B, Roman numeral 2, which radioactive emission is not deflected by an electric field. So radioactive emission that is not deflected or affected by electric field is gamma radiation. So gamma radiation is not affected by electric field or magnetic field. So our answer here is gamma radiation. We move to question C. So question C reads, a radioactive sample of mass 200 grams has a half-life of 8 days. How much of the sample would have decayed after 32 days? Okay, so after 32 days, so this is what we are going to do. First, we are going to find the remaining mass after 32 days. Then we know how much sample have decayed. So the initial mass is 200 grams. So after 8 days, this 200 grams will reduce to 100 grams. After 8 days, this 100 grams will reduce to 50 grams. After 8 days, 50 will reduce to 25 grams. After 8 days, 25 will reduce to 12 grams. So we have seen that we have 8 days, 8 days. So 8 plus 8 plus 8, we are going to come up with 32 days. So this is the remaining mass. Okay, this is the remaining mass. Now this is not the mass we are looking for. We are looking for the mass that has decayed, or the mass that has disappeared. Okay, we are looking for the mass that has disappeared. So therefore, we are going to say 200, the initial gram, minus the initial mass, 200 grams, the initial mass, minus 12.5 grams is equal to 187.5 grams. 187.5 grams. So this is our answer. Alternatively, we can also use this formula here. We are going to say the remaining mass is equal to original mass times half times n. Okay, so MO stand for initial mass or original mass. Then N stand for number of half-lives. So 32 divided by 80 is equal to 4. 32 divided by 8 is equal to 4. So we have 4 half-lives. Okay, we have 4 half-lives. Okay, 4 half-lives. So we are going to, where there is initial mass, we are going to write 200 grams times half to the power 4. So after making calculations, we are going to come up with 12.5. 12.5. So we are going to say 200 grams minus 12.5 grams. We are going to get 187.5 grams. So therefore, our answer is 187.5 grams. We move to the last question. So this is our last question, which is question D. State one way of handling radioactive materials safely. So one way to handle radioactive material safely is by using proper shielding, such as gloves, lab coats, and safety glasses. So this is one of the ways we can use to handle radioactive